Welcome to The Explainer. So today, we're digging into a super common puzzle in machine learning, something that honestly gets even the best developers scratching their heads: underfitting versus overfitting. It's this high wire act that you absolutely have to get right.
Okay, so picture this. You've been working for weeks, you've trained your model, and the numbers look incredible, like 99% accuracy. You're ready to celebrate, right? But then you throw some new, real-world data at it, and it just completely faceplants. So what is going on? Well, the truth is that amazing score, it might be a complete and total illusion.
To get to the bottom of this, let's meet our first suspect. We're going to call this one the lazy student. This is the model that, to put it simply, just isn't putting in the work. It's barely even trying to learn.
Now, the technical name for this lazy student problem is underfitting. This is what happens when your model is just, well, too simple. The algorithm itself is too basic to really get a handle on the complex patterns that are hiding in your data. It's kind of like it's just glancing at the surface, totally missing the deeper story right there in front of it.
Here's a great way to think about it. Imagine you have a huge final exam tomorrow, and your strategy, you just read the chapter titles. That's it. You might have a vague idea of what the test is about, but you're going to miss every single important detail you need to actually pass. An underfit model does exactly that.
And if you try to visualize it, the problem becomes really obvious. Let's say your data points make this beautiful, complex curve. Well, the underfit model comes along and tries to describe it with one single straight line. I mean, sure, it might point in the right general direction, but it completely misses the richness, the nuance, the actual truth the data is trying to tell you. All right, now let's swing to the complete opposite end of the spectrum, because there's a totally different way a model can fail. Let's meet our second character, the rote memorizer. This is the student who tries way too hard.
And this problem has a name too: overfitting. Overfitting is what you get when a model is so powerful, so complex, that it doesn't just learn the pattern, it starts memorizing every single little detail. And I mean everything, including all the random noise and weird flukes that just happen to be in your training data.
This rote memorizer is that student who gets a hold of the practice test and just memorizes it, cold. They can get a perfect score on it, no problem. And hey, that's where your 99% accuracy probably came from. But the second you give them a new question, one that tests the exact same idea but is worded just a little differently, they're totally lost. Why? Because they never actually learned the concept, they just memorized the answers. Visually, overfitting is just pure chaos. Instead of a nice, clean curve that shows the general trend, you get this crazy, frantic, wiggly line that zips all over the place, twisting and turning to hit every single data point perfectly. On the training data, it looks flawless, but that wild, unpredictable path makes it absolutely useless for predicting where the next point is going to land.
So, here's the real key. These aren't just two random problems. They're two sides of the very same coin. On one side, you've got the lazy student who doesn't learn enough. On the other, you have the obsessive memorizer who learns way too much. So how do they really stack up against each other?
When you put them side by side, it's crystal clear. The lazy student's model is too simple, so it misses the pattern. The rote memorizer's model is too complex, so it gets distracted by all the noise. One fails because it's too general, the other because it's too specific. And in the end, they both fail at the one thing that actually matters: performing on new data.
And that really brings us to the fundamental challenge for anyone building an AI model. Your job isn't just to avoid one of these errors. It's to walk that tightrope between them and find that perfect, delicate balance, that sweet spot right in the middle.
And why does this matter so much? Because the whole point of machine learning, the entire goal, is something called generalization. We build these things so they can learn from the past to make smart decisions about the future. A model that can't do that, a model that can't perform on new, unseen data, well, it's not just a failed model. It's basically a very complicated and very expensive paperweight.
So, let's just boil this all down. What do you really need to remember? Underfitting. Your model is a lazy student. It's too simple. Overfitting. Your model's a rote memorizer. It's too complex and it's obsessed with noise. The most important thing is that both of them will fail you in the real world. The true art here is building a model that finds that perfect middle ground, learning the real pattern, the true signal, and knowing how to ignore all the static.
So I'll leave you with this thought. The next time you're building a model and you see that amazing performance score pop up, pause for a second. Don't just take it at face value. Ask yourself that critical question: is my model really learning, or is it just being a lazy student or a rote memorizer? Because the answer to that question is everything.
It's the key to building AI that actually works.